you one of the latest effects I have made.
Well, I'm going to talk about the water, especially in...
I forgot to say, we could take advantage of this liberation of electrons by a sheet of barium silicated glass, which would stop the neutrons, and over this, nanofibers, where the electrons would hit and be condensed. Also, we could stop the chain reaction by part of another gas. Helium could be.
Well, I'm going to talk about water, especially in the treatment and catchment. Well, we proposed initially to send to Mars 5 tanks, about 20,000 liters each one. And this water will be stored on the underground tank. Well, we propose 2 ways to capture the water inside the greenhouse. One way is using the sweat of the plants, and it's called trans-evaporation. And it's necessary to have porous types to capture the vapor of the water. Another way to capture the water is using a channel, and this channel will be in this part of the greenhouse to collect the vapor of the crystals of the dome. And all this water we will send to an underground tank. There are 2 tanks, the principal tank and the emergency tank. After that, it's necessary that the water have a water purification system called a thermosiphon, and it's common in the swimming pool. Then the water is come to the surface and distributed in all the plants depending the amount of each one. If you know the plant don't use all the water, and the water that isn't used, it's going to return to the underground tank. Well, this is the thermosiphon, and only use a solar system. And if you see, the water is covered in all the system, and it's functioned by convection.
The electricity production, as I said, we are thinking of using the biophotovoltaic plates. They would be in a central tower, that would length 8 meters high. Also, the benefit of this would be in the dead space at the corners, so there are no tedious parts. I want to remark that we did the calculations to the wind turbines considering the velocity of the winds at 5 kilometers per hour. Mars winds are very, very faster. We would use energy at the centrifugal pump, at the lightning consisting of LED lamps, which would be distributed at this form, forming parallel circuits and series circuits for reducing the usage of the energy. Also, we would use in the air compressor and in the hair plates, because for the plants are more necessary template soil than a template vacuum. At the end, we would use this amount of energy, this amount, 136 kilowatts hour. This won't be a problem, because with the distribution I have just mentioned, we would produce 150 kilowatts per hour.
As an energy reserve, we thought about using a battery. If something goes wrong and our calculations are wrong, we have a reserve. We use this type of battery that's used in Curiosity rover, and it produces energy. We thought about failures. If there's fire inside our greenhouse, we would actually just take out the oxygen, and the carbon dioxide doesn't actually permits the combustion to be made. Then, if the dome is broken, we would just replace the part, because we thought about the dome with another thinner dome underneath the real dome. If we run out of water, there is water in Mars. We could actually collect it, and if the LEDs fade out, we would only replace them. They have an average life of 5 years. 5 years.
Thanks over, guys.
Yeah, we have finished.
Just conclude.
Well, as we said, we wanted to give a proposal that would encompass several of the topics proposed for this program. And as we said, we would actually encompass diet for a possible astronaut. We would have power sources, different power sources from the ones here, because we are actually talking about another planet. So there should be other types of energy. Then we talked about water, how we would actually recycle water, and how would we actually get water from Mars. And that's all. I hope you have enjoyed our proposal, and if you have any question, you could ask it.
Thank you very much.
No question?
I have a question. With the research and the technology that you use to make your dome, how can you use that maybe here on Earth where countries, their population are starving or malnourished? How would you use the technology that you have here to help
Yeah.
us here on Earth?
Well, they're used the polymer we decided to use for the dome, it's used to build stadiums, and also it's built to actually build greenhouses. So we think that this proposal could actually be used to give like the best of the conditions in several places. There are no conditions for the plants to grow. So this would actually help people starving. I mean, we could actually produce more food for these people.
This could be possible also because it really doesn't produce unproductive products. It don't waste water, it recycles.
Are you all thinking about presenting it to any companies or anything like that to help people?
We actually thought first we could present it here, and I mean, you could actually help us present it in other places because we have not the resources to do that.
Other question?
We have used photovoltaics on Mars, but wind, we haven't demonstrated it yet. We do know there's wind on Mars, but did you do any research on what's the atmosphere on Mars, the density of the atmosphere?
Yeah, we consider that with the wind turbine. I research about the density and just do a conversion. If a wind turbine here produces certain amount of electricity, and we have a density atmosphere of certain quantity, well, it will produce
The density is very, very low.
yeah, but they are. It is
Yeah,
really fast, and it is
the good part,
turbines.
yeah, the good part is that Mars has less gravity, so things weigh less there, so it's easier to turn.
Yeah.
So, you think that will be an advantage to your design?
One of the things I said, I think, were that we actually thought about vertical turbines. We decided also that it would be the best option because of the density of the winds.
If you see it, it is like a large area to capture the air. So it is not like normal turbines that they are just.
So your design worked good and to take advantage of the low, of the 3/8 gravity.